Hello, students. Today we're going to be talking about how to find the angle when you're given the lengths of the legs of a right triangle. So let's try this example on solar panels. South-facing solar panels on a roof work best when the angle of inclination of the roof, that is, the angle between the roof and the horizontal, is approximately equal to the latitude of the house. The latitude of Fort Smith, Northwest Territories is approximately 60 degrees. Determine whether this design for a solar panel is the best for Fort Smith. Justify your answer. So we want to find this angle right in here. Okay, right there. And in order to do that, we have to remember we're using one of our three trig ratios to help us solve these triangles. And from that angle, we know that the height of this roof is 9 feet, and from the center to the edge is 12 feet. That's the opposite side and the adjacent side. So the trig ratio that involves the opposite and the adjacent is tangent function. So we're going to use the angle that we're trying to find, which in this case is the unknown, and we'll call that theta. Theta is in here, if you recall, right here. So tan theta is equal to, and tangent is opposite over adjacent, so opposite is 9 over 12, and that equals 0.75. When you divide 9 by 12, you get 0.75. And in order to find the angle, theta, we have to use inverse function. So you'll notice that whenever you look at the function, there's a little minus sign above it, -1. That's the inverse function. So inverse tan. So you got to press your second function button and your tangent, and then the 0.75, or the other way, if your calculator requires it. 0.75, then the second function button, and then the tan button, and that'll give you the angle. In this case, when you perform that operation, you end up with 37 degrees. So the pitch of this roof is 37 degrees, and in Fort Smith, you want it to be 60 degrees. So is this design really good for Fort Smith? No, it is not. You need a larger pitch in order to receive the maximum amount of sunlight. Okay, let's try another one where we're finding the angle. I'm going to do option 1, and I'll get you to do option 2. So in option 1, we're trying to find theta. It's down here. And in relation to that angle, we know the opposite side and the hypotenuse. So the trig ratio that we'll use is the sine function. So sine theta is equal to, now opposite is 5.25 over 10.5. And you're going to divide the 5.25 with the 10.5, and you'll get 0.5. So sine theta equals 0.5. And in order to get theta, you have to use the inverse sign. Of 0.5. and that equals theta equals 30 degrees. Again, you're going to use your second function button and your sine button in order to get the angle. Okay, I'll do one more and then I'll get you to do some of these on your own. It says you have a rectangular piece of sheet metal that is 8 by 4, from which you need to cut 2 equal right triangles. What angle from the horizontal will you need to measure to make the cut? So again, if there are no diagrams, it's really great to draw your own. So we've got an 8 by 4 rectangular piece of sheet metal. There's my 4, 8, and we want to cut on the angle. There's my 90. So the question is asking, what's this angle going to be that we need to cut? So from that angle, I have my opposite side and the adjacent side. And so that's the tangent function. So tangent theta, use theta when we don't know what the angle is equal to, and then we will write the opposite's length and the adjacent length. Actually do this division. 4 divided by 8 is 0.5. And then you'll use your inverse tan to find theta. Inverse tan of 0.5 is 26.6 degrees. Okay, so one thing to remember in today's lesson is you're using your inverse function by using your second function button. So on the next page, there are 3 more questions, number 2, 3, and 4. You can give those a shot. And like always, I will be posting the solutions in the answer section of your Google Classroom. Take care.